Good morning, class. Today's lesson focuses on formula manipulation. I'm going to be referring to this document, which you will find posted in course documents of Blackboard. And there are 24 examples here. Many of these are electrical formulas, but there are also some simple general formulas for other areas of physics as well. So let's get started. Okay, in our first question, we're given the following. Force equals mass times acceleration, and we're solving for mass. We remember that we always perform the opposite operation. So if we want to isolate mass, we realize that right here we have multiplication. So what we have to do is divide both sides of the equation by a to get m by itself. So division is the opposite of multiplication. So our formula for mass is force divided by acceleration. The second problem is the same. We want to isolate L here, the inductance. 2 and pi and f are currently being multiplied by the inductance. So we do the opposite of multiplication. Once again, that is division. So the inductive reactance is divided by 2 and by pi and by f in order to isolate the L, which is the inductance. Okay, problem 3, we're trying to solve for current. Current is in the denominator. You should, of course, recognize this. It is Ohm's law. So we begin by multiplying both sides of the equation by I. This looks like cross multiplication as well. So this will give us I times R is equal to V. So that's the first step. Instead of division by current, we now have multiplication by current. Now again, you're trying to get the I by itself. Right now, the resistance is multiplied by the current, so we must do the opposite. So we end up with V divided by R is equal to I. Okay, so this required 2 steps. First, we multiplied by current. This was because the variable was in the denominator. So multiplication like this, cross multiplication, gets that variable out of the denominator. And now, instead of this multiplication by R, we now use division by R. Question 4 is just like question 3. So we're going to start with that all-important multiplication. So XC is multiplied by 2 pi f and c. Then we have the equal sign. On the right side will be 1. Now we're trying to isolate f. It is here. All of these other items are being multiplied by f. So in order to isolate the f, we divide by xc and 2 and pi and c, and you can write those in any order you like. The most common order would be this one. 2 pi is the numeric part, so generally that would be first. Okay, and now if you compare the original and final equations here, you can see that the xc and the f has simply changed places. Okay, but this was 2 operations just like number 3. First, multiplication, and then after, to isolate f, we use division. Okay, number 5, we now have a square in the formula. We're trying to solve for current. Now, the first thing you do is isolate I squared. Okay, so what does that mean? That means dividing both sides by R. Now we have I squared, the unit containing I isolated. How do you go from I squared to I? This is when you take the square root. The opposite of squaring is square rooting. So P over R will now be under a square root sign in our final answer, like that. Okay, let's continue. Number 6 is similar. Okay, we want a formula for V, the voltage. So we begin by isolating V squared. Instead of division by R, this will look like multiplication by R on the other side. The opposite of dividing is multiplying. Again, think of that cross multiplication here. So now we have this. P times R is V squared. How do you go from V squared to V? This is where you take the square root. Okay, so we end up with the square root of P times R is equal to V. Now, it's certainly fine to have the V on the right side, but if that bothers you in any way, of course, you can rewrite it and it would look like this. And that's the same with number 5, for example, as well. I could rewrite that if it bothers me, such that the variable I is on the left side. Okay, I could do that with number 1, number 2 as well, but it's certainly not required. All that's required is that you isolate the variable. Okay, number 7 gives us this voltage formula. We want to solve for P. Now this one is different because the P is under this square root sign. Okay, the unit containing P is isolated. So we have to start by removing this trapping square root sign. And that's done by performing the opposite, which is squaring. When you square the left side, you get V squared. When you square the right side, you will get P times R. Okay, continuing, we need P by itself. This shows multiplication. So the opposite of that is division. So we end up with P is equal to V squared divided by R. So that was 2 steps. First squaring both sides, then dividing by R. Okay, let's take a look at this problem, number 8. On problem 8, you should see 2 separate terms on the right side. And this is the first example like this. The terms are separated by addition signs and subtraction signs. So we have one term here and a second term here. So how do we begin to isolate T? First, we isolate the term A times T. So that means moving this to the other side. Currently, it's being added to AT. So we do the opposite, which is subtraction. So we end up with this. A times T is V minus V0. The opposite of adding is subtracting. Now we want the T by itself. We simply divide both sides of the equation by A. So that'll look like this. We will have A underneath V minus V0, like that. And that's equal to T. Okay, problem 9. This is a proportion. I know that you studied those already in this course. So let's have a look at this proportion. We want to solve for NS. Its square is in the denominator here. When you have a proportion, cross multiplication works really well. So I'm going to multiply this way first. So that gives me NS squared times ZP. Next we have the equal sign and we multiply this way. NP squared times ZS. So cross multiplication is a good start because we no longer have fractions, and not too many students enjoy fractions. Okay, now we're trying to isolate NS, so we will isolate NS squared. What does that involve? This is multiplication, so we do its opposite, which is division. So now we will have NP squared times ZS divided by ZP. So we have divided both sides of the equation by ZP. And the final step here, how do you go from NS squared to plain old NS? Well, you take the square root of both sides. So on the left side, we will have NS. And on the right side, we take the square root of the fraction. Okay, and that's perfect as a final answer. There is another way that we could write the right-hand side. So this is optional, it's not required, but since we have the square root of NP squared here, and since square rooting and squaring are opposites, this could be written with NP outside of the square root sign, leaving just ZS over ZP under it. Okay, so this is a little bit nicer. It's considered more simplified, but I would be perfectly happy if you left it at this final formula for NS. Okay, so cross multiplication, then isolate NS all squared. Finally, take the square root of both sides. Okay, number 10, you might recognize this. This is the area of a circle. Solving for the radius, first isolate r squared. How do we do that? Well, this is multiplication by pi. It's pi times r squared. So we start by dividing both sides by pi. And lastly, to go from r squared to r, we square root. So in our final answer, we will have the square root of a divided by pi is equal to r. Okay, let's continue. This is the 11th problem on the page. Kinetic energy is 1/2 mv squared. We want a formula for m. Now, we've got a fraction here of 1/2. This is the same as dividing by 2. Multiplying by 1/2 is the same as dividing by 2. We can start by eliminating this fraction if we double both sides. So we get this, 2 times the kinetic energy is mv squared. So that's a great first step. So we multiply both sides of the equation by 2. Now we want the m by itself. What shall we do with the v squared? Just divide. So 2 times the kinetic energy is divided by v squared, and that is your formula for m. Okay, so we first doubled both sides of the equation, and then to get the m by itself, we divide by v squared. Okay, let's take a look at problem 12. We're solving for R1. It is inside of this bracket. One way to handle this is to begin by opening up the bracket using multiplication. So I'll show you what that would look like. On the right now, you'd have I times R1 plus I times R2. Just like that. two terms separated by this addition sign. We want to isolate R1. So that means we begin by isolating I times R1. How do we do that? We change addition to subtraction. So it will be E minus I times R2 is I times R1. Okay, so in this step, instead of adding this term, we have subtraction of that term. Lastly, if you want R1 by itself, divide by I. And your final answer will look like this, with I underneath that difference. Okay, so the numerator is two terms. It's E minus I times R2. The denominator is I. Problem 13. A is VF minus VI over T. So this is an acceleration formula. We want to solve for VF, which represents final velocity. Okay. So maybe you can see that two things would have to be done. We have to move V initial. We also have to move T. Now the question is, what do you have to do first? You absolutely have to move the T first because it is under V initial. So first change division by T to multiplication by T, like this. It looks like cross multiplication, and that will give you A times T is VF minus VI. And now in isolating VF, change from subtracting VI to adding VI. And that is your formula for VF. Okay. Multiplication, cross multiplication again to start this problem. We've used that now repeatedly. Whenever we have a fraction on the right side, okay, which we did, by the way, back in number 3 and number 4, also number 6. Okay, so we begin with that. It looks like cross multiplication. So this time though, we're multiplying by two terms. So actually when we do that, we need a bracket like this around the two terms. Okay, because it's a binomial, two terms, so you need a bracket. And now we're actually gonna open up the bracket like we did in number 12. So we get E times little r plus E times capital R. Like that. Now we're solving for the capital R. So take a look. We've got these two terms on the left. So the first thing to do is move this term to the right. Instead of the addition, we will use subtraction. So that's better. The unit containing capital R is now isolated. Finally, change from multiplying to dividing. So when dividing by little e, we know that the little e will be underneath here, just like that in our final result. Okay, the next two formulas are essentially the same. This is what results when you use the Pythagorean theorem to solve for the longest side. So you might recognize this one, okay? C is the square root of a squared plus b squared. We want to solve for b. The first thing you have to do is eliminate this big trapping square root sign. So we start by doing the opposite of square rooting, which is squaring. So you square the left side. Now when you square the right side, the square root sign will be gone. Two terms here. We want this term by itself. Change from the adding to subtracting. Finally, go from b squared to b, and that involves taking the square root. Like that. And you can see that this will be exactly the same, except we now have a formula for impedance. Okay, this is when you have an AC circuit. All right, we want to solve for X, which is the reactance. The steps will be identical. First, get rid of the big square root sign. Next, isolate X squared using subtraction. And then finally, go from X squared to X by taking the square root of both sides of the equation. Okay, there we go. It may seem like I'm doing a lot of examples. I guess that 24 examples are a lot, but I thought that the more I do with you, the more clear the process will become. Okay, so thanks for your patience. Don't forget you could always pause the video as long as you promise to come back. Okay, so let's start with number 17 now. We're gonna solve for V. Okay, now there are many things we need to eliminate. 1/2 and m, and then the square. So we do these one at a time. First, to eliminate the 1/2, we saw this back in example 11. We start by doubling both sides of the equation. So 2 times Fs is mv squared. Next, move the m. This is multiplication implied. So here you will use division. And now you have a formula for v squared. It's 2fs divided by m. Lastly, how do you go from v squared to v? You take the square root. So when you take the square root of the right side there, you'll get v. If we go from v squared to v, we have to take the square root of the other side as well. Okay, so in your final answer, there will be a square root sign over that fraction. Okay, so three steps. First, we doubled both sides. Then we divided both sides by m. And lastly, we took the square root of both sides. Problem 18. We want a formula for V0. Now you probably can see 2 steps required. You have to move this term, and you also have to eliminate the square here. But what do you do first? First, you leave V0 squared where it is, and you must first move this term. So that means from adding, change to subtracting. And now we've isolated the unit containing V0. So we have V squared minus 2AD is V0 squared. Lastly, you go from V0 squared to V0 by square rooting. So the square root sign will appear over that whole left side, like that. Okay, 2 steps. First subtraction, then square rooting. 19. We want the g by itself. The square root sign is already isolated, and it's trapping the 2 and the h. So here we begin with squaring. Square the left side and square the right side. When you square the right side, of course, that eliminates the square root sign. So we have v squared is 2gh. Now you want the g by itself. you can divide by both 2 and h to do this. And so that can be done in one step. So we will end up with v squared over 2h is equal to g. Okay, so we have to square here first, then divide by 2h. Okay, number 20 is similar in its first step. We have to begin by squaring both sides because the unit containing r, capital R here, is already isolated. So we want to eliminate this trapping sign, just like 19. So we begin by squaring. So we will have I squared is P over R plus R. So two different R's, and you have to keep them different throughout the solution. Okay, now what do? We want to solve for R, but it's in the denominator here. That suggests we should multiply like this. Now, it's a binomial, so you know now that that means we'll need a bracket like that. Keep your eye on what you're trying to solve for. Open up your bracket now using multiplication. So I squared is multiplied by little r, then you have the plus sign, and then I squared is multiplied by capital R, like this. You want to solve for capital R here. There are still two steps. First, get the unit I squared R by itself. How do we do that? Well, P is already here on the right side. This term is coming over to the right side. Instead of the addition shown here, we use subtraction like that. Finally, get the R by itself instead of the multiplication implied here. This requires division. So that means I squared will be underneath, just like that. Okay, I think that was our longest one yet, many steps. So first, we squared both sides of the equation. We did the cross multiplication. This is a binomial, so it was bracketed. We opened up the bracket. Since we're solving for capital R and it's inside the bracket, we opened up the bracket. Then we subtracted I squared little r. Finally, we divided by I squared. So that was 1, 2, 3, 4, 5 steps. That was our record. That was our longest. Okay, next one, 21. What shall we do first? I like the cross multiplication to start here, so let's do that. A lot of letters in this one, but we're not scared. Okay, just like that. We're solving for T2. Why don't we open this bracket up using our multiplication? So what will that look like? That means the KAT is multiplied by T2. Then we'll have a subtraction sign. Then the KA little t is multiplied by T1. So cross multiplication and then open up the bracket. Since what we were solving for is in the bracket, that's why we open up the bracket. Now, you should be able to identify what the next two steps would be. The last two steps. Move this whole term first. What we're solving for is right here. So we're going to move this term to the other side. What will we do with it? Instead of subtracting, we will do our adding. Perfect. Lastly, we want this by itself. we divide by the stuff stuck to it. Okay, so underneath this sum will be the K, the A, and the little t, like that. And that is what we have as our formula for, it's probably temperature 2. Okay, so we cross multiplied. We opened up the bracket here using our multiplication. We moved this term to the other side because we're trying to get T2 all alone. So we got to move this guy first, adding. Lastly, all the stuff stuck to T2 is what we divide by. Okay, we're nearly there. We're going to do 3 more examples. So here is 22. Let's cross multiply first. Now, these are all subscripts, okay? So they don't affect anything, these little subscripts. So we start by taking the capital R and multiplying it by the capital I. Now we have 2 different voltages here, and we're actually trying to solve for this one. The unique thing this time is that it's preceded by a subtraction sign. Okay. All right, so the next thing we want to do, maybe there's a couple different ways of proceeding from here. If you don't like solving for something that's following a subtraction sign, you can actually move it to the other side using addition. So like this. Oops. I'm going to use my some correction tape here. Oops, maybe I'm not. Huh. What is wrong with my tape? I think it's out of position there. Oh, there we go. Okay. I don't really like to cross things out. Okay, so anyway, we got this term is already on the left side. I'm going to bring this to the left side so that I can change this to addition. So that's one way to handle it. And now what I'm trying to do, again, is solve for this guy here. So I'm going to move this term now to the other side using subtraction. Okay, so I hope that makes sense to you. When we started with our cross multiplication, we got this expression. And I did want a formula for VL, but I wanted a formula for positive VL. So I first moved this to the other side so that it could be positive. And then I moved this term, changing addition to subtraction. All right, let's try number 23. On the right side, we have 2 terms. One of them does not contain the A that we're solving for, and the other one does. So we know by now we should start by getting this term by itself. So this whole term can move, and that means beginning with subtraction. Okay? Now, to clear out the fraction, you know what you do. You double both sides, but this is a binomial. So when we double, we do it like that. Okay, remember that when you have a binomial, a bracket will be required. So even when we're doubling the left side, we have to put the 2 outside of a bracket. Lastly, we want the A by itself, just divide by t squared. So this left side now is going to have t squared under it, and that will be our formula for acceleration. Just like that. Okay, one more. We want the t here all by itself. Why don't we double both sides? And this is what we get. We get 2s is VF plus VI, all in a bracket, times t. Now, should we open up the bracket this time? The difference is we are not solving for one of the quantities inside the bracket. We're solving for this quantity outside of the bracket. What is implied here, right here, is multiplication. T is being multiplied by this binomial. So if we want to get the t by itself, we can just divide both sides by the binomial. And that will leave us a formula for t. Okay? All right, so we have now gone through together all of the examples on this handout. I hope that that was helpful for you. There are some problems in your textbook that I would like you to try. So please read the item in Blackboard. I've identified which questions you should try in order to further your practice with this topic. Okay, thanks so much for watching and have a great day.